Hi there and thanks for watching. If you like the content of this video, please like and subscribe. Welcome to 10 Minute Java, where I teach you guys Java in less than 10 minutes. Alright, today's topic is abstract classes. So I've got a Flamingo class and a bird class here. And if you look in line 3, it says public class Flamingo extends bird, which means Flamingo inherits from the bird class. So if we look at the bird class, we have things that might make sense for a bird, like feather color or size. All right, I kept it pretty simple. So we've got feather color, size, a constructor, and of course some getters and setters, nothing to see here. All right, let's go to Flamingo. Flamingos are different from regular birds in that they have a Boolean, whether or not they are standing on one leg. Okay, cool. So I can go to my main class. I can make a flamingo, no problem. Flamingo equals new flamingo, pink, size 10. Flamingos can fly. If we notice in the bird class, I have a fly method, all right, that allows birds to fly because that makes sense. And then, cool, everything's looking good. The problem might be on line 9. And we have to think to ourselves more conceptually here. So this is a perfectly syntactically correct thing to write. There's nothing wrong. The compiler is not yelling at me. But what does this mean in terms of our application? Let's say this is a bird watching app where we're looking at like birds that we would like to watch and get information on. So does it make sense to be able to instantiate just a bird? Okay, because when we think about birds, right, like bird is more of a category of thing. Okay, it's an idea. Birds, or there's an idea or description of a bird, and then there are concrete birds. Like a flamingo is a concrete example of a bird. Ostriches, penguins, pigeons, they're all birds. Everyone would agree to that. So bird really kind of refers to this more like larger, more abstract concept of birds. All right. So on line 9, I'm instantiating a bird, which basically means like, hey, I'm bringing it into existence. But what does this conceptually mean? It probably doesn't make sense in our bird watching app to allow our developers to just make a generic bird, because that doesn't make much sense. All right, so if I want to prevent my developers from doing this, I can. So I'm going to go back to the bird class. We're going to refactor it. What we got to do is go up to public class bird, and we're going to add the word abstract. Okay, public abstract class bird. All right, voila, you've made your own abstract class. Congratulations. Now, IntelliJ is screaming at me one related problem, and that makes sense. So we're going to go to it, and you'll notice in line 9 now no longer compiles. The compiler is yelling at me. Why? Because abstract classes cannot be instantiated. Okay, that is the #1 rule. Abstract classes, by definition, cannot be instantiated. You cannot do new bird. That is not a thing. Okay, the compiler will yell at you if you hover over it. It says bird is abstract, cannot be instantiated. Like, it doesn't get much more direct than that. All right, so therefore line 9 is no bueno. Okay, so therefore, if one of my programmers wants to use a bird, they need to use one of the concrete classes. So a concrete class would be any child class that extends the parent abstract class. So flamingo is concrete. Okay, flamingo is an example of a bird, right? And so it kind of makes sense, right? So abstract classes refer to things that are more nebulous, okay, like categories of things, or maybe like behaviors or whatever. Like, it is not necessarily something you could have in front of you, right? Whereas a flamingo is something you could have in front of you. Okay, it's a bird, but it is a concrete version of a bird. All right, now there's more abstract classes than this though. Let's go up to bird, and again, this is all the normal inheritance stuff. So if you have public methods, they will get inherited. All the methods and properties get inherited down just like normal. But we also can make abstract methods. So let's go ahead and let's think about this fly method for a second, because the parent class fly has the bird flies majestically, but maybe that doesn't really make sense for flamingos, right? Like, maybe, like, I don't know anything about flamingos, like, you know, and there's also ostriches, right? Like, ostriches like more run than fly. And there's other birds that might want to do something different. We could override it, or we could just basically say, hey, listen, if you're going to inherit from bird, we would like you to have this fly method, but you figure out what to do with it. Okay, like, we're not going to have the bird class decide how you fly, right? Because right now the bird class is deciding what the method fly actually does. Okay, if you run it, it will do line 29. So I'm gonna kick the football, kick the can down the road, and let the child classes figure that out. So what we're gonna do is we're gonna do public abstract void fly. All right, so we're gonna make this an abstract method. All right, it's gonna be angry at me because there's no body, so we gotta get rid of it. Okay, so there's no body to this. It's just basically a method signature, and voila. Now, what does this mean? Okay, public abstract void fly, okay, is an abstract method, but as you notice, there's no implementation, meaning there's no curly braces with anything in it. If you have that, it'll be angry with you. What this basically says is, hey, if you inherit from bird, you need to have a method called fly that returns void. Right, so if we go to flamingo, you'll notice that IntelliJ is angry with me. Why? Let's hover over it and look. Okay, class flamingo must either be declared abstract or implement abstract method fly. All right, so let's go ahead and do that. What we're going to do is we're going to go ahead and do an override. You don't necessarily need this, but it's good form. Public void fly. All right, and then notice how the compiler is now happy with me. Why? Because we made a method called fly. Now, if I do anything different with the method signature, so in the parent class, it's void and the name is fly, right? So I need to make so spelling is a thing, and it's void. It can't be like string fly or number or like float fly. Like it has to be void. Why? Because it has to match the method signature from the parent. All right, so now I've got this fly method, and now the flamingo, which is the child class, the concrete class, is going to have actually have code that handles what happens when a flamingo flies. So this is what I meant by the parent class is not going to decide how flying is going to happen. It's going to let the child classes decide that. It's going to be like, listen, you need to have a fly method. I'm going to make you have a fly method. You have no choice in the matter. But what the fly method actually does, that's up to you. All right, so the flamingo flies majestically. All right, I don't know. Okay, I have no idea how far flamingos fly. There are no flamingos where I live. All right, so to recap, you can make a class abstract. If you make the class abstract, then you can no longer instantiate it. So, for example, bird is abstract, therefore doing new bird is completely not kosher. You cannot do it. The compiler will not compile, Java will yell at you. Right, so this is no longer a thing. And we do that because maybe that would make sense. Maybe we want to prevent people from instantiating objects that don't actually represent real world things. So for example, bird is a category of thing and describes a group of things. It doesn't really make sense to have like a single bird unless I know what specific kind of bird it is. It makes sense for me to have a flamingo or a pigeon or an ostrich, but not necessarily to have like the nebulous concept of bird. All right, so now that I've made bird abstract, it can no longer be instantiated. Okay, you also have the inheritance works like normal. Okay, so like public methods will get inherited down, and then you can also have abstract methods. So an abstract method has no implementation. That means there's no curly braces with stuff in between them. Right, so that means that the parent no longer decides how the method's going to be used. But what this does do is basically says, hey, if you inherit from bird, you must have a method called fly. Right, so therefore, if I don't have a method called fly, let's take this out for a second, then I will get a compilation error basically saying like, hey, where's the fly method? You can even implement it if you want to, like through IntelliJ, you can do that. And then inside here, okay, you can go ahead and do whatever the heck you want, so like however flamingos fly. This is great for when you don't want the parent to make this decision. You want to make certain that fly happens because birds can fly in our app, but you don't necessarily want to have like a one size fits all. You want to basically force the programmer to think, okay, how do flamingos fly? How do ostriches fly if they do? How do pigeons fly? And this is basically forcing people to like answer that question. All right, so that's abstract classes, and hopefully that wasn't too bad. You can try to go ahead and use them. They work. The rest of it works like general inheritance, but again, you can do abstract methods, and abstract classes cannot be instantiated. That is the big one.